video. All right, let's take attendance. Welcome, Brandon. Oh, I meant to make you guys a Google form. I forgot. Do you though? Do you?
Alternate, decrease, and
Oh my god, wait, can I not write the whole sentence? Can we just have to say that absolutely everything?
Yes, it would be nice if you could tell me if it converges at all.
Do we have to, or do we just have to say that it?
Okay.
Wait, the series does sorry. I know that. Am I over this?
All right, Liza gone.
She's here.
Well, she's gone right now. Sushan gone. Sachi. That was a scary noise. Where are the twins? Is Liza doing a handprint too?
Yes.
All right. I have some words for the SCA.
They always call us at the end of the month.
I'm gonna have some words for them. Yeah, be ready. Or like, don't follow as many people. You hear me on video SCA. Many ish. All right, let's talk about this. Let's kind of do it together. So, first things first, I want you to tell me if this converges at all. What test are we going to use? So let's just say out loud. Since the terms alternate, decrease in magnitude, and the limit of what? All right, perfect. So we're talking this limit without the alternator goes to 0. This limit does go to 0, right? All right, a couple of you guys, that should be a 4th root, not an nth root, excuse me. Doesn't really matter for the limit itself, but yes, it matters for the question. A couple of you guys were doing weird things with limits. If you have a number on the top and ends on the bottom, that thing's going to 0. Then that converges by alternating series test. So we've got the convergent part, right? So what do we do now? Yeah, so we're going to, a good word to use would be to consider. What series am I going to consider? This one without what? Yeah, effectively, I need to absolute value this guy. So that's going to kill off the alternator, and I'm going to be left with 1 over n to what power? 1/4. Now I'm writing this as a power series because p series, that would be helpful. What is this p in this case? Why do I care? So what? I have you guys trained so well. Yeah.
So if we wrote comparison,
No, probably not.
didn't write A. I moved it
That's
out.
probably fine. As long, so the one big thing that I did notice overall on problem sets and on the test when I did a quick glance, you want to be really careful about what you're setting equal to each other. I'll give you an example in a second. But so what's the answer to this question, by the way? Conditionally convergent. Do make sure you write that somewhere so you're actually answering the question. So going back to kind of the linkage issues, a lot of people, this came up a lot on the problem sets with nth term test, funny enough, also on the quizzes. Some people were trying to do nth term. So let's say I was doing 5n squared plus 1 over 6 minus 2n squared. That would be a good one for nth term, right? Yeah. All right. Tell me what's wrong with this statement right here. All right, there's no limit. That's fair. Yeah, when I say, and this goes to that question with the eyes in it too, when I say this equals this, I'm saying the sum of this is -5 halves. Well, if I'm about to say diverges, this doesn't have a sum at all. So you really need to make sure your equal signs are making sense. So the thing that should be equal to this is the limit as n approaches infinity of this guy. So some of your tests may be lit up a little bit with the yellow highlighting. You just have to make sure your equal sign actually needs to mean equals, because I can take off points, as can the AP test, if you're using equals when it doesn't mean equals. All right, let's talk about alternating series error bound. That was rough. All right. So, fair. No, that's fair. That's fair. Whenever I see a lot of blank questions, I'm like, probably should have spent some more time on that. So determine the number of terms to be within 1/65. So the what? It did. It didn't take forever. It took less than 10 terms. I don't know anyone's test. All right, so this one you shouldn't need a calculator. This one also asked for the properties of the series that make this true. Since this is alternating series error bound, what properties do you think the series needs to have? Alternating, decreasing in magnitude, limit of 0. So you have to have a convergent alternating series. So I would recommend the lazy way with this one, meaning start listing out terms until you get one that's less than 1/65. It should be relatively simple to see how many terms that needs. All right, then start to think about how you're going to answer your question. Should we list out the terms together? I'm just bored up here. What's the first term?
-1.
Is that small enough? All right, what's the next term? Is that small enough? What's the next term? I like asking the same question over and over. Is it small enough? What's the next term? Is it small enough? All right, so I need to make it up to 8 squared, 25, 36. We're just working on whiteboards. 49, 64. Were you doing handprints? Is that why?
Yeah.
I have words.
Well, the thing is, for lunch, they don't set it up.
Yeah. It's not your fault. No, whose fault it is. All right, so I found the term, right? I found the term. This one is less than 1/65. So let's talk about how to answer this question. So this is the 8th term, right? The 8th term is less than 1/65. So let's answer the question. How many terms do I need to have the sum be within 1/65? Try again. Try again. 7. All right. 3rd time's the charm. So let's talk about alternating series error bound. We claimed that the error, which we could write a couple of ways, we wrote it R sub 8 or R sub 7, excuse me, or the sum minus the partial sum at 7. These are less than the next truncated term. So the next term up. So if I add up these 7 terms, the reason that we are within 1/65 is the next term up, the 8th term, is less than that. Sir. Oh, I lied. I don't know fractions. Hold on.
Yeah. I was like, it's 164.
All right, let's adjust now that I know how fractions work again. All right, ready? Ready? What's the next term? You know, I meant to write this question like this. That's why. All right, now that I know how fractions work, thank you, Austin. It's been a long week for all of us.
Yeah.
And we still have 3 weeks before spring break. All right, let's start over. So our 9th term is less than 1 over 65, which means our remainder for 8 terms has to be less than that. So our answer, are we now all on the same page now that I remember how fractions work? Wow. I'm about to just add +1 to everyone's test because that's embarrassing.
You should, yeah.
All right. Yeah. Remainder. No. So let's talk about the directions to the question. The directions to the question said state the qualities of the terms of the series. So that's alternating, decreasing, and magnitude limit of 0. You just said determine the number of terms. So as long as I see 8 terms and some sort of explanation as to why I'm stopping here, it doesn't have to be as formal as this. I'm good with that.
Oh, wait, so the qualities was just the
Mm-hmm. Yep. So essentially, we just need a convergent alternating series to be able to use that arrow bound. It was straight off the review, but whatever. All right, let's do one more error bound, and then we'll talk about E really quick. All right, so the other error bound question, now that I'm hoping I remember how fractions work. All right. Wow, y'all, that's really embarrassing. It's not. It's not, though. All right, yeah. I won't edit the video. It's just going to be. All right, I want you to find the 4th partial sum, the error bound. So this is the one with the 3 blanks. And the interval. There's a reason why we're doing this. All right, I gave you an easy series to deal with here. Yeah.
So, you know the question we just did?
Yeah.
One of the on the test, one of the questions was what about the series allows like the line?
Yeah.
Is it like the decreasing positive?
Yeah.
was like the R, 8 or something, like the 8, I got the error bound. So that could be right for error bound, like that little bit right there.
You could just write a number.
You just write like the 8.
The number that is, yeah. Yeah. So let's talk this one out. Fourth partial sum. What am I doing? Plugging in 1 through 4, adding them together. So what's my first term? Second term? Next term? Next term? Cool. All right. For sake of writing the interval without having to add these fractions, I'm going to call this S sub 4. All right, now my error bound. This is something that I know is definitely bigger than my error or bigger than my remainder. What is that going to be? All right, it's going to be 1/5 because I'm looking at the absolute value of A sub 5. Yes, or the decimal. Now, how am I going to write my interval? How do I find that interval based on the stuff that I have? I add and subtract. So you would want S sub 4 minus 1/5. And S sub 4 plus 1/5. You can put your sum in between them.
So did we do that on the last one?
No. Yeah, there are several. If you want more practice on this, there are several questions on the review that are explicitly just like this. The error bound is your next term up. So if I do the 4th partial sum, I'm looking at the 5th term. If I do the 99th partial sum, I'm looking at the 100th term. Yeah. Yeah.
What would happen, like, if you're looking for the 100th term when you ask for the 100th? That's right, everything.
Yeah. Or you could use your calculator if you find segmentation, but I didn't actually do that many times.
Can we just write exactly that? We have to actually, like,
I would like numbers here. So I'd like number less than number.
You don't want, like, on the test, you don't want to.
No.
You want to actually add.
Yeah.
But we can do A sub, or do we just do one?
So ideally, this would be decimal number, decimal number, decimal number, decimal number. All right, last couple. I just want to know what this is asking for. What is this asking you to do? Yeah, it's asking you to find the sum. I only know how to find the sum of two series. Geometric and telescoping. Which one is this? What's the first term? 2/7 to the n. What's the ratio? Cool. Can you simplify a fraction? Yes. All right. So you're just trying to find the sum. So if I'm asking you what a series is equal to, I want you to find the sum. All right. The last one, if you would like. Now, there is a clever way to get around using integral tests on this one. It was meant for integral tests. I'm not going to tell you the clever way to get around it. You have to be clever to do that. At least one person has been clever on the test. It was not in this class that I saw. It's fine. You don't have to be clever to be good at calculus most of the time. It's an N. I was just writing quickly. You could also write it dx. It doesn't matter what letter you use. If this makes you feel better. As a hint, what would you do to figure out this question? How is figuring out the even difficult?
I don't know, because I feel like
Where's your function inside another function?
You're surprised? Well, I was looking at it, I was like, I don't think it works, but wait, I'm so
Why? All right, help me out. What's the derivative of x to the negative 2? This? All right, I don't have the negative 2. Where's the x to the negative 3? This is the x to the negative 3. So all of this, this is your du. It's the x to the negative 3 on the bottom. If you need to write it out like e to the 1 over x squared times 1 over x cubed. Yeah, exactly, with a negative 1/2. All right. Yeah.
And that bottom one is also equal to e to the 1 over x squared times x to the negative.
Yep. All right. If you, yeah, a lot of people try to get really, really creative. All right. If you want to finish that one out, great. If you don't, that's also great. What I'm going to do is I'm going to start passing out notes for today. What? No, you have to integrate it. A lot of people had questions on the problem set, actually, of like, can I leave my final answer? Because the one that had arctangent on the problem set, the answer was really gross. Really, for integral tests, you just need to know that you get a number or you don't get a number. So don't feel like you need to simplify that much. But if you do, simplify correctly. Otherwise, I will highlight it or grade it, I guess. So make sure you're simplifying here. That power on the e, I think, is going to go to 0 with that infinity. But e to the 0 is not 0. I saw a bunch of people dropping that term. So yeah. So just make sure that you're looking at that. Since this one is like almost explicitly the same as the test, I'm just going to leave the rest of it up as a mystery. You should get convergence by integral test. Also for integral tests, what 3 things should I observe about the function at the beginning? Positive, continuous, decreasing. If you see me ask about like, what do you know about this function? That might be something. If you're looking for any other help, this test tends to be one where either you kind of got it or you didn't, at least from like previous years of teaching this test. So if you find yourself in the didn't category and you would like to move yourself to the got it category, I'm here in the morning. Just let me know. Also, several of you are missing assignments, like mostly this test. I put in zeros in the gradebook to motivate you to come take it. If you're one of those people, maybe start thinking about that. The quarter ends before spring break, and that's a hard deadline on things. So start thinking about whether you'd like to turn in some things and take some tests. Up to you.
Will we have another unit test?
No, this is actually the last unit test on this quarter. We got to push 9 and 10 to fourth quarter, so you guys actually have something graded in fourth quarter. Yep. So April 8th.
Does that mean that after whatever the test is a good time to take things?
Yes.
Okay, cool.
Will we have like?
We might.
Wait, so.
Yeah, we might take unit 9 before we leave for spring break, but it'll go on. We will take unit 9 before we leave for spring break, but it'll go on fourth quarter.
So basically, all right.
All right, so you guys can put your whiteboard materials away. I know we didn't finish the 9.1 notes, but I want to go to 9.2 because it's a big old review of ratio tests. If we have time at the end, we'll go back and finish those 9.1 notes. I really love this section, so hopefully you do too. We're going to do 4 problems today. We'll take 5. I got one. I love this. Sorry. Oh, and I can use this. All right, let me get.
No, we did do it, but it was
Oh my
like.
God, my name looks so bad.
That's what I was saying.
All right. Dunday, dunday. All right. Are you? I'm not ready. No. It's a not just today occurrence. I'm not going to yell at anyone. I don't yell at anyone. I'm just going to express discontent would be a good word. I don't like, there are several instances in my teaching career where people have kept more than a significant portion of my class doing something else. I had about a third of my class that got kept in class to take a test. I was very angry that day. So it was like their 6th block, they were taking a test and they were coming to my 7th block. And the teacher was just like, they can stay to finish the test if they want. Oh, yeah. I had to send my department chair to go get them. No.
Well, no, but dang it. Well, for the students, teachers are.
Oh, yeah. I didn't blame the students at all, but then they came to my class and they were pissed at me because I fetched them from their class. It was just a bad day. Bad day. All right. A good day, though. Interval of convergence. I love this topic. Also, you got a pretty good shot at this being a free response question on your AP test. Effectively, interval of convergence is a very, very fancy way to find a domain of something called a power series. So let's talk about all those words that I just said. The test that you guys just took was all about what would be called a series of constants. It was a bunch of numbers we were adding together. Now, a Taylor series is not that. It's a series, but it's not a series of numbers. It's a series of stuff with letters in it. And you might have noticed last time that a lot of those things had like x minus our center to a power. Now, Taylor series are a type of power series, but really anything where I have x's to powers like this can be classified as a power series. So what we're going to try to do today is we're going to try to find out for what values of x do these series converge. When you think about finding values of x where something like works, that's pretty much a domain. So we're using like 10,000 words and about 12 years worth of math to find a domain. So that's kind of what a power series is. It's just got constants in front of these x minus c's, which could be like the Maclaurin series, just x minus 0 to some power. So power series, that's why I didn't call it like a power series test, because this is a power series when we did P series, if anyone cares. So there's 3 options. I'm going to show you the first question. It's probably going to take us like at least 20 minutes to do this question. It will take us a full page, and I'm going to need you to write small. There are 3 ways to do this question. I'm going to show you the hardest way first. So I guarantee the first problem we're doing is the hardest one by far on the notes. The interval of convergence. We have 3 options. We're going to see the second one here first. Our options are our series can converge only at our center. Our series can converge literally everywhere, or our series can converge within a certain number of our center. And that certain number that I can travel out from my center is called the radius of convergence. So how far I can travel from my center to still get things that converge. So this is our radius. It's just a lot of really big words for not a lot. Our radius of convergence, again, can be 3 different things. It can be a number. So that second bullet point there, we can get a number for our radius, like 4 or 2/3, a positive number. Our radius could be nothing. So if I only converge at my center, my radius could be 0. I can't travel anywhere from my center. Or if I get a radius of convergence that's super big, I could converge everywhere. What do you think I mean by super big? Wow, y'all are brilliant. Yeah, at least I need you to think so for the next couple of minutes. So, like I said, there's a reason I gave you this whole page. Look at my notes. You need a whole page. I'm going to need you to not write big. You don't need to write too small. You're going to write small. Now, this one is probably on par with like a relatively difficult version of this question, but this is by no means the hardest version of this question I could give you. They're all about the same difficulty level. The nice part is they all have very similar steps. So we're going to kind of walk through the process. I think I put 2 versions of this on the problem set that I have printing for you. So you can practice it a couple of times. If we get to this notes check today, it's going to be very high stakes because it's just one problem. So you either get 100 or a 0. That's it. Yeah. Yes. Mm-hmm. So, well, 99% yes. All right. So what we're going to do is we are going to find both the radius and the interval of convergence. What test did I say was going to make a rapid rediscovery today? Ratio test. So ratio test is how we're going to do this every single time. The 1% that I was talking up here about is there's sometimes we can do this with geometric, but ratio test will be our go-to. So ratio test. This is not a geometric series though, so too bad. Me too. All right. So how did ratio test work? What did we do for ratio test? Perfect. So let's stop there. We're going to, every time we see a n, we're going to add 1 to it. Now, you'll notice there's a lot going on in this series, including that x. In terms of what we're doing right now, the x is going to be treated as a constant because our variable for our limit is n. So x is just going to hang out. So our -1 to the n plus 1, what's that going to look like now? Wow. All right. X minus 5 to the n is going to look like x minus 5 to the n plus 1. What's the bottom going to look like? Perfect. And we're going to make sure, oh no, okay. And in parentheses here. All right, so that was the first part of ratio test. I'm not going to close my absolute value bars though, because I have to multiply. Oh, no, I'm not. Sorry, I got to enunciate better. All right, what's going to go on this side? All right, reciprocal of the original. I could do a big complex fraction and divide these, but it's a lot easier to do the original. It looks hard. It's not that bad though. So this is one of those where the process itself is not going to be terrible, but it looks terrifying. All right, so let's talk about some of the things that are happening here. The first thing is I'm going to cross out 2 of the factors that are in my fraction because I don't think they matter at all because of those absolute value bars. Anyone think they know what I'm saying? The negative ones. Now, some of you out there are going to be like, yo, Miss Hefty, I don't like writing things. Can I just not write the negative ones? No, you have to write them in your first step. I know they're silly and I know they're going to go every time, but I talked to a grader and they're going to get mad at you and they're going to take away your points if you don't write the negative ones. So as soon as we get here, we can cross them out. Just to very much verbalize why we can cross them out again. No matter how those negative ones cancel, they are going to give me one of 2 numbers, 1 or negative 1. Right now they're canceling into one singular negative 1. The absolute value of any of those options is 1. So it doesn't matter. All right, so as soon as we get there, cross them out, we're done. Now, the next step, we are going to break this down just like we broke down our old ratio test. So I'm going to be looking for things in mostly the left-hand side of this fraction that I can break up the exponents. Someone who thinks they know how to do ratio tests, how might you break up the numerator? All right, I'm going to take all of those little mumbles and do what I think I'm supposed to do. Is that what you said? Cool. All right, thoughts on the bottom. What would you break up on the bottom? Yeah, the 2. I can't do anything with this n plus 1. That's not going to do anything. So I'm just going to break this guy into 2 to the n times 2. All right, I'm going to keep this guy. Now, this is a really long problem. I would recommend not trying to keep all these steps in your head. Write them down. Writing's not that bad. What did you say? Oh, all right. Canceling time, the best time of ratio tests. What can I cancel? All right, x minus 5 to the n's, go away. What else? All right, 2 to the n power, go away. All right, anything else? All right, I have a very specific question because some of y'all are getting crafty. Can I cancel these ends? No. Everyone give me their Scout's honor. I will not cancel these ends anymore. Even if they're n squareds and they look really, really cute and I want to cancel them really, really bad. No, stop. No, you got a +1, buddy. Got a little +1, can't cancel them. All right, so I'm going to take the leftovers and I'm going to organize them. Is that how you do Scout's honor? I only did like 1 year of brownies. Is that the right term? Yeah. Yeah, I was like, I don't like this. All right, I'm gonna separate this a little bit to be a little bit more specific right now because this one's our first problem. We got a little bit of a weird situation here. The weird situation, we have not done ratio tests when there have been x's before. So I'm going to just pull those out to the side for a second, and then I'm going to look at the other stuff. So I have n over n plus 1 times. Actually, I'm going to write this the other way around. I don't like putting the times 2 at the end. Sorry. Freak me out. 2n plus 1. All right. let's talk about each of these pieces individually. I would like to talk about this one first. I think everyone in this room should know at this point where this limit goes. Where does it go? 1/2, right?
Oh yeah.
Why is it 1/2?
Oh,
All right, we have n on the top, n on the bottom. Ratio coefficients. What? You could distribute it, and if that makes you more comfortable, 1/2. Now, let's talk about this guy. As far as our limit goes, what variable is in our limit? Look at the variable for our limit. N. A weird question. Is x n? No. So with respect to this limit, is x a variable? No, it's a constant. And the limit of constants is just themselves. So every time with this limit, we have to keep the absolute value bars, but we're going to be left with the x minus 5 or whatever our thing is. All right, the n goes away because for this one, this limit is 1/2 because of the limit, and then the x minus 5 has to stay. All right, so here's a new and novel part of this question. We now have not just a number at the end. When we got to ratio test, we usually got a number at the end. Does anyone remember what we did with that number? We compared it to a number. What number did we compare it to? 1. So I'm going to write a sentence that I usually probably wouldn't write. I'll show you what I probably would write. So we know that this series will converge when this fraction that we got as a result of our ratio test is less than 1. Yes, definitely. All right. A lot of the time you'll see people just go up here and do the less than 1 here as kind of an extension of their step. That's fine. If you want to be explicit and actually write this down, this is fine. All right. Now I'm going to multiply this 2 over, because once I isolate this guy, this is x minus our center of our power series. Once I isolate that, this number right here is my radius of convergence. I can hear people color coding. It's just funny when you hear all the pens drop at the same time. All right, so the cool part is we're done with our ratio test. The sad part is we're probably about halfway done with finding the interval of convergence. So if we were asked for the radius of convergence, we're pretty much done. For the interval of convergence, the part we need, it's a little bit confusing. We know that our center, anyone know what our center is of this series? So I want a singular number. What's the center of this series? 5. All right, I get it because x minus 5. All right, so 5 is the center of this series. I know that I converge out 2 from either end. So what's 2 to the left of 5? 3. 5 minus 2 is 3. What's 2 to the right of 5? 7. Now, the way you can algebraically do that, I don't think they teach compound inequalities that much anymore. With the absolute value, you can set this between -2 and 2, and you can add 5 to all 3 sides. An easier way is just to think about, okay, I have the center is 5, subtract 2, add 2. The part that's annoying, I know that everything between 3 and 7 works. Everything between 3 and 7 converges. But what about 3? What about 7? I have to test them. It's not that bad. All right. It's not that bad. It's just a little nasty. All right. So do you guys want to do 3 or 7 first? Who votes for 3?
Yeah.
All right. I'm going to scroll up to the very top of my question. And I'm going to plug in for this X right here. So I'm testing a very specific number. I'm testing 3. I'm going to plug it in way down here. So the series is going to stay the same. The -1 to the n plus 1 is going to stay the same. Now, x minus 5 to the n is now going to become 3 minus 5 to the n. What's 3 minus 5? All right. On the bottom, there weren't any x's, so I'm just going to copy it. N times 2 to the n. That looks terrible. But it no longer is a power series, correct? There are no x's left over. So this is a series of constants. This is something I could have just put on your Unit 8 test. So now we have all of the tools to figure it out. So one thing I'm going to tell you is usually this can be simplified down to something that's pretty darn nice. So we're going to try to do that. Yes, this is probably the whole thing together is probably on the free response. All right, so let's go ahead and try to simplify this a little bit. I am going to try to break up this numerator a little bit because I'm seeing, anyone else see that like -2 to the n on the top and then the 2 to the n in the bottom? I feel like I can break some stuff up with algebra to kind of cancel some stuff, move some stuff around. So I'm going to break this into -1 to the n plus 1. And I need to tell you, to tell me if the next thing I'm about to do is legal. Can I make this -2 to the n into -1 to the n times 2 to the n? I cannot do whatever I want. I can't just say this is equal to 3.
But I guess -1 is always 1 or -1.
Yeah, you can. It works.
Yeah. Do you think that do you think I'm legal? All right, I am. It is. You're not convinced? Yes, you can do that. All right. What I can't do is leave off the denominator. So let's not do that. Yeah. What do you see? What do you see that's good? The 2 to the n's. Get rid of them. Bye. Yeah. All right. Let's simplify one more time. I see a lot of -1s. No. But these are the same base of -1. So what can I do to the powers? All right, I can add those powers because they have the same base. So I have -1 to the 2n plus 1. Kind of. We still have to do 7 too. All right. This is starting to look familiar. What does this kind of look like? It kind of looks like a harmonic, right? With the n on the bottom. All right. It should look like a harmonic a little bit. But remember, it could be also an alternating harmonic. And that changes whether things converge or diverge, right? So what does the regular harmonic do? Diverge. What does the alternating harmonic do? Converge. All right. I'm going to give you about 30 seconds to try to figure out whether it's alternating or not. I'm going to give you some rules for how to do that. Try to plug in 1, 2, 3, 4 to n and tell me, is it going to alternate? All right. Question. Does it alternate? No. What is -1 to the 2n plus 1 always equal? -1. So I'm going to write this series as -1. I'm just going to pull the negative out front over n. Actually, let me write this up here because everyone's going to get confused. All right. I could write this out front if I want to make it look more like an harmonic series. But this guy is harmonic. So it does what? Diverges. Now, what did I learn? I do not want to put the or equal to there. Wow. Ma'am.
And I would do it again for 7. Oh.
Say that again.
So when you plug in 1, 2, 3, whatever,
Yeah.
if it's negative, it's harmonic, positive.
So the reason we are calling it -1 is because if we plug in 1, we're getting 3, 2, we're getting 5, 7, 9. So if it were even the entire time, I would still want to call it the harmonic because we'd be getting 1 over n. When it would alternate is if I had if I plugged in 1 and got -1, 2 and got +1, 3. So we'd want it to alternate. Right? Liza? Because I add the exponents. So n plus 1 plus n. All right. So again, what I have learned here, our interval of convergence, we're working with from 3 to 7. What I learned from all of that is I don't want to include 3. Brandon's right, though. We need to continue. We still have to check 7. All right. What? I don't know. Let's find out. I say I don't know because I don't want you to think you know based on what one does. They have no impact on each other. Oh, you did it. Okay. Some people are going to be like, well, one converges. That means one diverges. No, that's not how it works. All right. So I'm going to do -1 to the n plus 1 is going to stay the same, just like before. N times 2 to the n is going to stay the same. Now I had x minus 5 to the n. What number am I plugging in now for x? No. 7. So 7 minus 5 is 2 to the n. Now, see, no one listens to me. You just try to throw numbers at the wall. And you're like, will this one stick? All right. Do I have to do a lot of algebra for this one? Feeling sassy today. Sorry.
Someone who forgot how fractions work, you are sassy today. Yeah.
Cold out. To be fair, that's a fair burn. That's a fair burn. All right, let's see if you guys remember anything. What's this? What's this?
I'll say harmonic.
Are you sure? All right, so again, I don't know if you guys heard me talking to Ashley about this guy, but the reason this one's alternating, think of plugging in 1, 2, 3, 4 to that top one. That guy is going to go from, if I plug in 1, it'll be -1 squared, which is +1. Then it'll be -1, +1, -1. So the reason the other one wasn't is that we got -1 every single time. So this does converge. So let's talk about what I learned. I learned, bam, wow. So if I'm answering this question, the question asked me for the radius of convergence and the interval of convergence. So my interval of convergence will be 3 up to 7, including 7. If you're a fan of interval notation, you could also write it like this. Doesn't really matter. But let's talk about what the heck that means. So again, this is like a domain. So looking at this series, I could plug in anything between 3 and 7, including 7, and I could get a series of constants that converge. So let's see if you understand what I just said. If I plug in x equals 0, will I get a series that converges? All right, good. Why not? All right, it's not between 3 and 7. Give me a number that I can plug in that will make a series that converges. 7, 4, 6. What about 11 halves?
Yes, you can.
5 and a half? Yes. All right. What about pi? What about e? No. All right. 2.718-ish. Yeah, what about 2e? All right. So, like I promised, this is definitely the hardest question. We're going to try some when we come back to represent the other two examples of when we converge only at the center and when we converge everywhere. But I wanted to do this one first, partially because this is probably the one you're going to see if you see one on the free response. You're definitely going to have to do one in a notes check, and you're definitely going to have to do at least one on the problem set. That being said, the rest of the notes are a lot easier. So there we go. But that's the process. So before we go to break, tell your neighbor, pick your favorite neighbor. And pick Austin. And I would like you, someone give me a mood. All right, you can choose. I will either give you happy or angry. Take that mood and explain this problem to them. The outline. What did you do? I would choose angry personally. So, for example, my first step. Can I be angry at anyone? Yeah. Lily, gosh darn it, do the ratio test first. Adding 1 to the power and multiplying by the reciprocal, and then continue. Take about 30 seconds to angrily go through this problem, or happily. I'm not very good at being angry. All right, take about 30 seconds. All right, I feel like no one. All right, I feel like no one's actually explaining the problem. Or are we all? Do we all choose happy? You said it. All right, can anyone give me a first step here? What are we doing first? Ratio test. All right, tell me, what did you guys say after ratio test? All right, so I solve and I kind of get the radius of convergence by making sure I have the x minus my center isolated on one side. How did I get from the radius of convergence to like this part?
You're testing.
Cool. I actually like that. So if you don't like the algebra, I really like the way Zach's describing this. Take the center and go this way in either direction. So -2 + 2. That's a perfect way to get to this part. All right. Someone tell me what I was doing at the end.
Plugging in the value.
All right. I'm plugging in my 2 endpoints. I should get a relatively easy test. A lot of the time, harmonic will come up or something like a geometric. You're usually not going to have to like pull out a limit comparison test. It's not going to be that aggressive, usually harmonic or alternating harmonic. All right, let's take a solid 4 minutes. Actually, you know what? You guys deserve it. Let's take a solid 5. We'll come back and we'll see the easier versions of this question.
How many notes are you?
Oh my God. No. The orange little fluff ball that talks about eating rainbows. Yeah. Kind of.
Like, if you're trying to get me to see that.
Right, invested.
Yeah, it's not free.
About 40 minutes.
Right now.
And then I also
I have backpacks.
can binder.
Do you have backpacks?
Probably 3 minutes.
Oh. Well, I have to do it.
Right, I know.
And I wrote from my details. I mean, I'm just like. So we did the middle version of that, it's the hardest one.
Yes.
So it's how large ratio.
We have 2 things.
And you're like, that's
Like,
Or did you get?
Me too, but it's due Monday. No, and this is due, we need to be there.
Oh, it's Friday.
I think.
No, plus you're both doing.
Oh, I mean, I think I'm on right now, I'm really.
Same, but you also, we also need the librarian.
I don't think.
But it's been all day, all day, so we have to. Well, you have to get over this. Oh, you can't. Well, you can come in on, well, not even.
Hello, everything else.
I'm gonna try to stop happening. If it doesn't work,
You'll see it a minute.
maybe we can land and drop off your.
My brothers.
Wait, really? Yeah, I have that.
Yeah.
They're partying.
You are, right, my son aces.
I would try to.
Well, I don't know, that's what I'm saying. No matter how.
Also, I don't know, it just.
Oh,
It's gonna be a secret.
Okay.
It's like, I don't really.
We're allowed to do it.
No,
As long as you like.
don't do it. I can play.
Yeah, I we got it.
And hope that one has.
General go.
Possibly win.
I do both.
But, I might know the point.
Like it's only like.
Right, you don't want any more access.
I don't think it's that bad.
My personal life than they already have.
Okay, that's okay.
They're on.
I have a question on it. Okay, so. But like, what I mean, how do you know it's negative? So basically, if you plug it in, you say like, if I plug in, say, 3 here, 2 times 3 is 6 plus 1 is 7. So, how does that Now, like, can you give this again? If you don't make it
So your negative square is negative. No, not until so like negative x plus. And then you have negative Yes.
All right, let's go ahead and let's look at the easier versions of this question. So if you remember on the front page of these notes, I said there were 3 different options for an integral of convergence. So we've done this middle one where there is a certain radius from the center that we can go to get things that converge. We're now going to look at what happens what would happen within my ratio test for me to get converges only at the center or for me to get converges kind of everywhere. So that was fancy. Let's look at this guy. This one's fun. All right. What's the first step? Ratio test. Now, I like this one a lot. Oh, this is actually one that we're eventually going to memorize. Do you guys remember the Taylor series that had odd powers from last class? Okay. This is actually equal to sine of x. Yeah. Yeah. Actually, no. Negative sine x. Yeah. No, sine x. Sorry. Didn't plug in the right number. All right. So let's start with what's the negative one now going to look like? Negative 1 to the n plus 1. Now, I want to be careful about the next power, so I'm going to do them in a couple of steps. Remember, we replaced the n with an n plus 1. I'm going to do that in parentheses because I'm going to have to distribute that too. Because I was really excited about that too. Sorry. And it's Friday. Better? All right, now I probably wouldn't write this in 2 steps like I'm doing right now, but I just want to be really, really explicit about what I'm doing. I don't want to just add 1 to whatever the power is. I need to plug in n plus 1 where the power was. All right, what am I multiplying by? Because we're plugging in n plus 1 where the n is. The n's being multiplied by 2, so we have to multiply the 2 by the whole n plus 1. All right, let's see who is paying attention. I'm going to cross something out right now. What is it? Get out of here. Absolute value bars, killing them off. Do I need to write them though? It feels like I don't need to write them. Gotta write them. All right. Let's take a couple of steps here. I'm gonna simplify my powers first. So this is honestly, if I were doing this question, this is probably where I would start it. So I'm gonna distribute this in and then combine the constants. So I'm going to have x to the 2n plus 2 plus another one. So x to the 2n plus 3. All of this 2n plus 3 on the bottom. So notice that's not 2n plus 1 plus 1. It's 2 times the quantity n plus 1 plus another 1. So just very careful there. Ooh, I got your guys' attention. Don't know how. All right, ready to break down some factorial and stuff? All right, so I'm going to try to be a little strategic here. So how much bigger is this exponent than this exponent? By 2. So are you guys cool if I do x to the 2n plus 1 times x squared? All right, those would still add together to get 2n plus 3, but I'm looking forward. I want to cancel with that one on the bottom, so that's how I'm going to break it up. I could do x to the 2n times x cubed. I'd get the same thing, but this is just going to be a little bit faster. All right, I'm going to copy the. Actually, no. Let's do the bottom first. All right, how did it work to break down factorials again? All right, 2n plus 3. 2n plus 2. Now, should I stop there? Okay, I'm going to do another one. 2n plus 1 factorial. And Jill and Connor are getting excited because the 2n plus 1 factorial will cancel with the 1 over here. So that's where I can stop where they're going to match. All right, I'll keep the 2n plus 1 factorial. X to the 2n plus 1. Yeah, sorry, I should have centered it. Wasn't thinking. All right, what will cancel? So descriptive. I love it. It's fine. Half the time, all I hear is. I'm not saying it's you. No, it's the collection of people together. Yeah, because other people are answering too, bud. It's not just you. I also have ringing in my ears. It's a lot happening. Genetics. The entire my entire mom's side of the family just has screaming ears. It's called tinnitus or tinnitus, as my ear doctor said. I think that sounds pretentious though. So, all right. Oh no, I know I'm not alone. There's lots of people. All right, ready? Are you ready for this limit? All right. With respect to this limit, what is the variable? N, which means x is not a variable. X is a number, which means I have a number over stuff with n's in it. This limit goes to 0. Now, the reason this question is going to be easier than the last question, there's no x's left over. There's not going to be a way for me to create an interval of convergence like I did here. So there's not any x's left over. So this is like the ratio tests we've done before. What do we compare to? What number? 1. How does 0 compare to 1? All right. Was that good or bad? That means it converges no matter what x is. So let's talk about the 2 questions we want to answer. The directions for this, they're on the last page, but it's find the interval of convergence and the radius of convergence. So if this is going to converge, it's going to work no matter what x is, what do you think the interval of convergence is? So the interval of convergence, negative infinity up to positive infinity. You could write it like that or an interval notation. This is effectively the all real numbers of interval of convergence. Yes, so no matter what value of x I plug in, I will get something that converges. Essentially, the x value didn't matter. All right, so what's the radius of convergence? How far can I go from my center? Infinity. So some strategic questions here. What is my center?
1.
There is a center. 0. How do I know? Do you see like an x minus anything? No. So this is a power series centered at 0. Give me another place besides 0 where this will converge. Cool. Give me a place where this will diverge. Nowhere. It'll converge everywhere. All right, last one. This, in context of this limit, is a number. So we've got like 3 over 2n, like n squared effectively. So as we go to infinity, bottom's growing huge, top is staying the same, go to 0. All right, last one. Now, some people were asking before we went to break, how do I do ratio test when it's not a fraction? Don't multiply by a reciprocal, just divide. So we're going to do the n plus 1th term on the top. What's the n plus 1th term going to look like? All right, and then I'm going to divide by the nth term, which is n factorial over x minus 6 to the n. All right, let's break up that numerator. Thoughts on breaking it up? All right. On the bottom, I'm going to keep n factorial x minus 6 to the n. What cancels? All right. Interesting. So what I have left is n plus 1 and x minus 6. Sick. All right, well, there's not a fraction here. Can't compare powers. X minus 6 with respect to this limit is a constant. So where does this limit go? Pretty big. All right, again, we are getting a result of this limit that is not contingent upon the x value. So why do I care about infinity? Perfect. Wow, that was very formal. I liked it. So this is definitely bigger than 1. So what this usually meant for us, what did this usually mean? Usually it meant diverge. Now, I want to show you a very specific place because I didn't give you an option up here, and I'll scroll back down. I didn't give you an option up here of, hey, this diverges everywhere. The option we're at is actually the first option where we converge only at our center. And I want to show you why we will actually still converge at the center, even though this is producing something that says diverge. Let's, you wouldn't formally have to do this, but we're going to test our center. What is our center in this power series? 6. I know that because I'm seeing the x minus 6. So let's test our center as 6 as our x value. So if I plug in 6, I'm getting n factorial. I'm plugging in 6 for x. Okay, cool. What's 6 minus 6? 0. All right, so I've got n factorial times 0 to the n. Let's list out some terms, shall we? What's the first term? What's the second term? What's the third term? If I add up infinitely many zeros, do you know what that adds up to? 0. And is that a number? Yeah. So that actually does converge. And every center, because of the way we construct a power series, it has x minus something in the center, will converge. Now, the first term, sometimes the first term is a constant that's not 0, but this always will converge. So no matter what power series you have, it will converge at the center. So let's talk about what we would actually answer. So our interval of convergence, how would you say the interval of convergence? Where does this converge? All right, the center, which is 6. There's a couple of ways to write it. You could write x equals 6 if you don't want to think too much. A couple of years ago, I had some sassy boys who were like, well, how would you write that in interval notation? There's actually 2 ways. I looked it up. You can do 6 comma 6, which is creepy, or you can just be like 6 in brackets. They thought they were smarter than me. No. All right. No, one of them challenged me to a math off. We were doing a review AP test, and Max beat me. Max actually may be smarter than me. All right, let's talk about our radius of convergence. Radius of convergence. Remember, the radius of convergence is how far can we go from the center to get things that converge. So how far can I go from the center? I can go 6 away from the center and converge. 0. I can't go anywhere from the center. It only converges at 6. I know, right? All right, so let's finish up with a little bit of thinking, and then we may just open next class with some practice. What time is it? 41? 41? I want to finish this. All right. I want to finish this idea really quick.
So all we would need to write like, so that's like our.
Yeah.
Do you want to cover the radius if it was, is it converge or not?
What?
So, yeah, so if the radius was like, converge at like 6, just write that.
Yeah. So if we had a radius that was a number, we would have this situation where we would want to go both sides from the center and test the endpoint.
Oh,
All right, let's finish up this conversation. Actually, maybe we'll save this for next time. Let's save it because I want you to practice. So we've got some time left. I'm going to ask you to do one question. This is something where you need to practice. So you have one question. Highest stakes notes check ever. I'm not fixing before you leave. You got about 10 minutes to do a single I'm going to tell you it's this version. So if you're getting infinity or 0, you're wrong. They're very similar. It's also not alternating, so it's not scary. So you won't have to do quite as much 10-point mess as I had to. I can absolutely guarantee there will be one of these on your Unit 9 test. And I can guarantee this is one that every one of you can do if you practice it. It's a very methodical question. If you didn't realize, start with ratio tests.
There was one day I was trying to delete emails and I had 600 emails selected and then it unselected all of them. Okay, is my email not all bad?
Why are we comparing our emails?
I got a notification that was like, you want to delete 3,000 emails? And I was like, sure, and I pressed it and it took care of 3,000 times.
10 gigabytes. I am not going through 40,000 emails.
I still have not hit my goals. I am not looking forward to it.
I don't think it's anything.
They're like, I said that a lot. Nothing going wrong.
I know it's so funny.
Oh, what's that? Did I post it? So it should be X plus 2.
Yeah, in your app.
Oh, I just now realized I did.
Okay, before you move on, let's
I know, I'm thinking class, I said it.
No, I really like that.
Oh my god.
I need to wait.
The first time I read it, I beat it in the same one and just every end. Then when I reread it, I read it,
Oh,
I just flipped it, but I don't have to do end.
Wait. Oh. All right. For your limit, you should be in the situation where you're getting x plus or minus something all over a number. Yes. If you're not getting that, you made a mistake. If you want to check what you think your center is and your radius, I can tell you looking at your question.
I feel like I'm doing.
I did the first term.
You dropped. I can cross all of these now.
Oh,
I can cross out all but
when
one
I'm
of them.
changing these, do I change it
Still
to
have
silver?
like and don't drop your ass. Yes. Is it all over a single line? Yeah.
Yeah, so when you take the limit down, so just like oh,
What's that for?
oh.
Oh, shoot.
You know when, I don't know, when I'm trying to make positive, so yes. No. Hello. Yep,
Be careful about this doing 10.
Oh, I'm also
Plus
doing.
one absolute value.
I don't think I can wait.
Oh. Yeah. Too late. Doing the problem.
Okay.
I write in one too. I think it's so much. He's like, you should have been loud enough. But I don't even have them. I'm gonna use. I have a pencil for writing on my phone. I don't have them for.
Okay. Right? Yes. But how is that less?
This is the fun.
So, you know our series Convergence went back. So now you're in the process of trying to break up.
I'm not on the right.
Oh, that's just fun.
So it would be like,
Oh, no, what?
-3 to the end, you can pull out and then.
That's a statement.
Hello.
Then it's up.
It's alternating.
Oh. One of them is good.
Figure out the negative between the two.
Yeah, so that.
Well, that's what you get after.
So
You
you
got
got
the
the
thing that you get.
and then alternate,
Yeah.
so it's not like.
Oh,
it'll be negative.
The whole thing.
Oh.
Oh, so
Okay,
that's
that's right, but.
on the side.
When you rewrite it, after doing your.
Yeah. But this on
I think I figured out some C right here.
It's just like that.
Yeah. Do you have a question about?
So, one way, you take the center,
Right.
minus 5, and closer minus 2, or you can set 7 So I think your center is probably 3.
All right, can everyone just pause where they are? Pause where you are. If you are done, I will take it. If you are not done and you don't want to think about it over the weekend, I will also take it. If you're like on a roll and you would like to finish the question, feel free to take it with you. We will fix these next time. What's also happening at the beginning of next class? Round 2. Let me know if you need anything. Otherwise, thank you for your time today. 3 words. And your limit needs to stay there.
If they're both harmonic divergent, then you not have harmonic.
One of them shouldn't be harmonic diverging. Where'd your -1 to the end go? That doesn't just turn into -1. We had like a 2n plus 1. That's always odd. So that one was always -1. That one's not always going to be -1.
Oh, does it become -1? Oh.
Sometimes, depending on what n is. So I think it needs to stay -1 to the end in there.
Okay. Oh, and then it becomes an alternating harmonic. And then it converges. So then
You'd want to include that endpoint.
So if it's alternating, then just do it.
I would just leave it like this.
Okay, and then it's safe.
I'm losing my mind a little bit for this. Is this like the right thing so far? Just this.
Center is, I don't like your center being 2. So usually these numbers will match up. So that's,
Okay,
that's
yeah.
why
I was like,
it's a little weird.
this is
So your center, it's usually x minus the center.
Okay.
So x minus what gives me x plus 2. Thanks, Austin. Do you have the other one? There's 2 forms. Oh, maybe. Huh.
X minus what gives you x plus 2?
Yeah, so if I wanted this to look like x minus something, I'm not asking it the right way.
I'm so lost.
Do you agree with me that x minus -2 is the same thing as x plus 2?
Yes.
So -2 is your center instead of
Oh, okay.
If
that
positive
makes-
2 is your center, it would look like x minus 2.